This video covers chapter 8 of our textbook, which is about producing data and sampling. So what are we going to cover in this chapter? I'm so glad you asked. So in this chapter, we're going to cover population versus sample, how to sample badly. That's something you don't want to do, so we need to learn how to not do what we don't want to do. How to create simple random samples, also known as SRS. Gaining inferences, so inferring things about our population, other types of sampling designs, some concepts about sample surveys, and lastly, the impact of technology on sampling. So I maybe should have started with this in the beginning of the semester, but what is statistics? Well, statistics is not only like the science and study of collecting, analyzing, and interpreting data, but statistics also refer to the data that we collect about people, subjects, right? Something that summarizes something. We see statistics in the news a lot, right? We see polling, graphs of, heat rising and inflation at this time, right? And there are lots of statistics about people, especially. We collect statistics about our population, health, education levels, sports, finance, all those things. So that's kind of like what is statistics. And when we want to study a population or learn something about a population, sometimes it's not always possible to study everyone in that population. And for that, we need a sample. So, for example, what if we wanted to study all college students, right? We cannot study all college students. The population is just too big. So for that, we need to take a sample. And sampling is when we take a portion or a subset of a larger population, and we call that portion the sample. And what we use is the information we gain from our sample to make inferences about our population. So keep an eye out for these. First, a sound statistical design is necessary if we're to trust data from a sample for drawing sound conclusions about a population, right? The study needs to be designed well, right? And when sampling from large human populations, keep in mind that even with a sound, like solid statistical design, there can be still many practical difficulties that may arise. So we need to distinguish between a population and a sample, right? To make sense of any sample result, we need to know what population the sample represents, right? The population in a statistical study is the entire group of individuals that we want information about, right? And a sample is a part of the population from which we actually can collect information, right? It's a small enough subset that we can study. And we're going to use the information from our sample to draw conclusions about our population. A sampling design, which was what we're going to talk about later on in this video, describes exactly how to choose a sample from a population. And there are many, many ways to do that. So the first step in planning is a sample survey, right? So like, let's say we want to survey a population. We aren't doing an experiment here. This is observational. Is we need to say exactly what population we want to describe, right? I can't just say college students. Maybe I want to say first generation college students. Maybe I want to study first generation female college students. Maybe I want to study first generation female college students who are parents, right? Like we need to narrow it down to make sure we've got our perfect, population. And then what we want to do is say exactly what we want to measure. So we have to give exact definitions of our variables if we have them. So once we've got our population, right, it has a parameter. So a parameter is a numerical characteristic of an entire population, right? And then from our sample, we'll calculate a statistic. So a population has a parameter and a sample has a statistic, right? And for example, 1.8% of college students in the US are nursing majors. Would we be a good sample? If our class was a sample, what's our statistic? I think our statistic's actually 0. I'm not sure of the 17 of you taking it right now. I didn't think I saw any nursing majors. So what percent off are we? Well, we're off by 1.8%. We're not a good representative sample. And a main concern of statistics is how accurately a statistic represents a parameter. Now, in order to get our sample statistic to be a parameter and be a good estimator, we need to make sure our sample is representative of the population we're studying, right? Like I said earlier, when studying the population of college students, we wouldn't want to select only women or freshmen, right? Because that sample wouldn't be representative of all students. The sample must contain all characteristics of a population in order to be representative. So we need men, women, non-binary folks, right? We need freshmen, sophomores, juniors, seniors in order to have a representative sample. So we take our sample and we calculate sample statistics, and that's numbers that define the characteristics of our sample, right? And then we can use those, as long as we have a representative sample, we can use those to find a population parameter. So let's talk about some sampling methods. So the first one is a census, right? A census is the collection of data from every member of a population. In the United States, we do a census every 10 years, right, to see how our population has shifted, to distribute resources and Congress for people, right? But we can't do that every year, right? I'm pretty sure the census costs like $1 billion. Like, that would be very difficult to do if we were studying college students. It'd be a lot of work to speak to every college student, right? So this is not typically our go-to method to study a population, but it is necessary for governments at points in time. One way we can find a sample is to use simple random sampling. So we choose a sample of items in such a way that every sample has an equal chance of being selected. So for example, you want to conduct an opinion poll in which the population is all the residents in a town. Could you choose a simple random sample by randomly selected names from the local property tax records? Well, no, right? Not everybody owns property. I have an apartment, right? I would have been excluded, and anybody who rented or was unhoused would be excluded from this sample. So this isn't like a good way to pick a random sample. Let's talk about some good ways to pick random samples. So a simple random sample, right? It uses chance to select our sample. That's this, principle of statistical sampling. So if I have a simple random sample of size n that consists of n individuals chosen in such a way that each had the equal chance of being selected, like I mentioned earlier. So in practice, we use random numbers generated by a computer calculator to choose our samples. And if you don't have a technology handy, you can use a table of random digits. I have one coming up in a couple slides. So how to choose a simple random sample. So a table of random digits is a long string of the digits 0, 1, 2, 3, 4, 5, 6, 7, 9 with these properties. Each entry in the table is equally likely to be any of these 10 digits, right? The entries are independent of each other. That is, knowledge of one part of the table gives no information about any other part. Like, this is truly random. So how do I use a table of random digits? So the first thing I need to do is give each member of the population a numerical label of the same length. So I wouldn't have like subject like 1 and 10. I could give them all 3 digits, right? Then we're going to read consecutive groups of digits of the appropriate length from table B, and my sample contains the individuals whose labels I will find. And we're going to go through an example of this. I know this is strange, but this is what a random digit table looks like, right? Like, here are lines, right? And every one of these digits has the same opportunity of occurring. So let's say I had a population and I gave them all three digits. So it's like 100, 101, dot, 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 dot. I have all these students and I've assigned them all these numbers, right? So I'd go through and I'd say, okay, 192 is in my study, 239, 503, 405, 756, right? All those individuals would be in my sample. Let's look at a more flushed out example. So let's use the random digits provided to select a SRS of 4 hotels, right? We want a simple random sample of 4 hotels. So I would pick from my random table line 69. Well, that one doesn't work because that doesn't appear. 05, oh, that appears. We have Beach Castle. 16, that's one. Radisson. 48, we ignore that. That doesn't work. 17 works. Oh, I think this is animated. 17 works, Gold Star. So we picked our Ramada. 87, that's a no-go. 17, that's a repeat, so we skip it. Another repeat of 17, right? And lastly, 20. So we've got our sample of 4. And if I needed to, I could have gone to another row of the simple random sample. So here's our simple random sample, and then we can collect information about these 4 hotels. So there's our, or we could have used technology to randomly find a simple random sample of 4 hotels. We can do this automatically in R, as well as you could use a table.